name is Jeff Lomas. As Matt mentioned before, I am here in Las Vegas, and today we're going to talk about Ethereum. So some of you let's talk about the reason why I did this. Is more and more I'm running into Ethereum in my own work, and I have a lot of questions from other people that I work with and other people that I know, and they get those things confused with overall cryptocurrencies such as Bitcoin. So we're going to talk about that in a little bit. First, to understand where I'm coming from, this is, I do work in law enforcement. I work for Las Vegas Metropolitan Police Department. I'm a detective, been there for about 13 years. I also teach for SANS, teach a Sec 47 OSINT course, and I also teach for private university as well. And if you, my Twitter handle is down below, and you can hit me up in the hallway as well if you have any further questions. But my perspective is coming something from an investigative sort of thing. I am not the person that you want to ask for any sort of legal advice or for investment advice, because my perspective on this, I look at cryptocurrency as investigation. So it's a problem to me. So something that I'm solving. And so I'm not somebody to ask for advice on those things. But what I can say is that if you want to get into this sort of thing and you want to, to tinker around with it, it is completely open. That's why we are having this Ethereum talk here, is because it is so related to OSINT overall and understanding the basics on how these things are all related. So at its base, Ethereum is just basically a bunch of transactions. It's a network, a decentralized network. It's kind of like other cryptocurrencies. And within that network, people can do things like send messages to each other. There can be messages within contracts. There's all kinds of interesting pieces of information that we'll see a little bit later on that we can pull out from these things. So because there are, again, this is all financial type stuff, there are relationships we can start to draw. Now, you do have to have a certain amount of context to understand what these relationships are. But once you're, from your starting point in your investigation, which is we'll kind of do a couple different mock investigations. So we have to understand those contexts and how it fits in with the relationships in this investigation. And we can see things like business relationships. Is it going to an exchange? Are they transferring it to another wallet that maybe they control or somebody else's controls? Are they switching out the types of crypto assets from one thing to another and then sending it on to another place? So we're looking for modus operandi or sort of tradecraft that they might be using. Those are important things that we'll be looking at here. But first, I want to get the differences out here. So we are definitely not talking about Bitcoin here. Bitcoin tracing, ETH tracing, the way the cryptocurrencies work is you can see there's some similarities. But if you can always think about it this way, Ethereum was always just a response to Bitcoin. We won't talk about the shortcomings of Bitcoin and the problems of the network and proof of work, which also is what Ethereum also suffers from in terms of efficiency and speed of transactions and cost. But the major thing to take away between these two things that was added to the Ethereum network is kind of built in is down here, these contracts here at the bottom. So if you can see these contracts, we're going to talk more about contracts in just a second. But these contracts is really the biggest thing that you're going to see the differences in. Now, can you send messages and can we see relationships on the Bitcoin blockchain? Yes. It's all public information. It's all available. You can understand the context. So these transactions and messages are actually kind of built into Ethereum, and then they're done for a certain purpose. The great thing about today is that Ginsburg is going after me. Michael James is going after me, and he's going to explain a lot more of this stuff. So if you have questions, send it to in the hallway, but we'll get into some of those things as well. So let's talk about the basics of an ETH transaction. Now, with every ETH transaction, it's just kind of like Bitcoin, where you need a wallet. So think of a wallet as just a place where to hold value at. And with every wallet, if you're going to make a transaction to someplace, you're going to have a transaction hash ID. That's part of the proof of work. So a bunch of machines doing a bunch of math, and these transactions come out so that no transactions can be duplicated. That's where the trust comes in. That's where people can know that their value is not going somewhere else. They can be satisfied that one transaction is going from one place to another. Now, one thing we always gets confused about the Ethereum blockchain is about these ERC20 and ERC721. There's a whole bunch of other types of tokens that can be that operate within Ethereum. So think about Ethereum as this. So Ether itself is just the mainnet. So you can trade Ether on Ethereum mainnet, and or what some people call L1. Again, these terms are interchangeable because this is just a thing made by people. So you have L1 stuff. Now, if you think about ERC 20, 721, that starts to get into the realm of maybe L2 or layer 2 type things, or bridges, or whatever people want to call them. You'll see the difference here. And the way that Ethereum makes it go from just Ether, so just trading Ether back and forth, to these tokens, and again, transferring these tokens back and forth and changing the value of them, or the denomination of them, if you will, is these contracts. Contracts are what makes the Ethereum great blockchain interactable. It also is what makes it very vulnerable, because these contracts are written by people. They're written in code, and we'll see that in just a second. But again, there's a lot of human error that's going to come along here, because it is designed by humans. Now, I don't know if you have access to a cryptocurrency tracing tool, some kind of fancy thing. I do. I have access to those because I do work in law enforcement. But even though I work in law enforcement, even though I have access to these tools, I still use free tools such as etherscan.io. So etherscan.io is just a free site. They put up the information, and what they do is give us the ability to look at these transactions. So if I'm looking at something on a paid tool and I don't quite understand the relationship, and I want to make sure that I understand a transaction, I simply put it into Etherscan, because A, it's free. You don't need to sign up for an account. By the way, everything I'm doing today, you can do as well. You don't need any special tools or anything. And within Etherscan, it also gives us things, what we call attribution on the blockchain. So when we say attribution, we mean some sort of information that has been added to a wallet or a contract or anything that gives us an idea of where it comes from. Okay, so let's think about attribution as a cryptocurrency exchange. Very important. A lot of people pay for those tools that give them that information. Etherscan has that for free. We also have people that go on and they do what we call user source comments. So people get ripped off by somebody, they get scammed, and they say, hey, this is a scammer wallet, or something was in the news, and then they relate to that. And so the entire community, because again, this is the community that's being used, especially when we're delving over into Web3, is the entire community uses Etherscan.io. It's very, very popular if you're in this space. Only way I can really show it to you is to actually show it to you how it works in real life. Okay, so what I've done here, I know there's a big thing about these QR codes, and people are nervous about them. A guy I work with he'd rather die than scan the QR code. I don't know how extreme you are, but there's a ETH address I can share with you later on, or you can just simply scan with your phone. All it does is go to etherscan.io. I tried them all out myself. I generated these myself. And we're going to look at this address. So this particular address here, I'm going to share this over here with you. So this particular address here, I'm going to go over here, is, again, nothing that's involved in investigation. I'm going to call it this 0x, so hex 5849. And the way we normally talk about these addresses, we just kind of talk about the first few digits so people understand what we're talking about, because again, they're very long, just like a Tor address. And I look at this and I go, okay, by the way, this is not involved. There's nothing scammy about this. I don't know who this is. I literally just went to Etherscan's main page, picked out a wallet that was doing some transactions, and this is the example I chose. Now, since I chosen it, there's actually been some transactions, quite a few transactions since it happened. So again, I don't know who this is. We can see, the sort of value that's with this particular, somebody's posting over in the channel that the value's gone up a little bit. The value of ETH does go up and down. Transactions go in and out of this thing. If I pressed, refresh on my screen right now, it might even refresh to, an additional transaction that goes through, because this is real time. So within here, I can see all the different transactions, and I can see everything that I need to see as far as this person goes. So now, can I tell who this person is just through this wallet? I have no idea. But what I do know, I'm looking at all these things now, some of these are ENS names, which Michael James will talk about later on. But we can see down here where we have a cryptocurrency exchange, Binance. You see a number next to it, 18. That doesn't really mean much for us, but it just says it's some kind of node or wallet that belongs to Binance's, put some funds, crypto assets into this wallet. Now, if I wanted to click on that, so I'm just going to click on this first link right here, okay? Just this 0x143. This is a transaction hash ID. I click on it, it takes me to a screen that shows me the exact information. So for whatever reason, Etherscan likes to count down in days how long it happens. Now it does tell us, March 21st at this time. And remember, anything that happens on most blockchains is always going to happen in what we call UTC. And that's just done for uniformity purposes. So down here, we can also see things like, okay, the value of the transaction that happened here and now. This is a pretty straightforward one. So what could I look at from this transaction to go, okay, what's the relationship to here? Well, first, I'd have to see, how many transactions are coming from Binance. Is there a possibility that this is a hot wallet that's connected to Binance's outer structure that the users basically using as their wallet that Binance has assigned them? It's possible. Could there be KYC or know your customer data from Binance as somebody in law enforcement, or if you're working in civil type things, you can send a subpoena out to you and find out who that is? Yes, all those things could exist. So whenever something comes from an exchange, we have that what we call a weak part in the chain where we can gain that insight or that context to understand what's going on. Okay, so now that you have some sort of idea about how these are working, we can look at other things like, okay, let's say we go on the ERC20 side. So we have these little tab here across the top. We have these internal transactions. We're not going to worry about that right now. But see, this wallet has ERC20 and ERC721 tokens that they've been interacting with. So if I click on the ERC20 tokens, now it'll show me all of the transactions that are happening within the ERC20 ERC20 tokens. Okay. Well, what those are is basically happening on the Ethereum mainnet, but it's another layer that's happening within there. So these transactions are being conducted through Ethereum blockchain, but again, these things are in these token values instead. So that's the kind of thing that some threat actors like to do, is that they like to change tokens back and forth. So it makes it very hard for us to trace those things. Okay, so is all of changing tokens all malicious activity? No, it could be related to investing, but these things do come with fees. So again, just like I would do with another transaction, this person's dealing in some Uncle. So we have 2 Uncle tokens, and we can see how Uncle tokens are being transferred from some unknown wallet over to this wallet. We don't know the relationship here. Of course, we'd have to trace backwards on that to figure out where that came from. So looking at ERC20 transactions is no different than looking at ERC than regular Ethereum transactions. Very similar, but again, you have to remember to click across these tabs and look at the things from that aspect. And we'll go into this more later on, but I want to give you a quick example of what we'll be looking at when we look at these transactions. All right, so we're back. So it's at this point, you're wondering what a contract is. And you just kind of saw a contract in the previous transaction looked at, because it is an ERC20 contract, because it has to interact with something. Some other code has to be running within the Ethereum blockchain for this to actually make sense, for these transactions to actually happen. That code is written by people. So contracts are basically, they're sitting on a wallet. So people think of contracts as just contract. Well, it's a wallet and it's a contract. This code that's been basically running on that contract. So think about code is when something happens, another thing has to happen in kind. So maybe it's some kind of if and then statement. It can be all kinds of code. You'll see the code is going to be written in Solidity, which is the main code that's written in these contracts that's hosted on the Ethereum blockchain. That's how they have this interoperability between these things. So is it helpful to have coding experience? Sure, yes. We're actually going to look at a contract, and I'm going to show you that it's not that hard to look at it, but again, the more experience in this field that you have in OSINT, things of basic coding skills and things of that nature do help you in other things, even when it comes to tracing crypto, believe it or not. So we're back to the QR codes. Now, we'll set your mind in this scenario. So let's say you want to invest in crypto, and a friend of yours told you that Shrootbuck office, the office of reference here, Shrootbuck is somehow a great investment, and they want you to get into it. But in looking into it, your friend didn't really know what the short name for the token was, and so you start doing some research, and you find 2 different Shrootbucks. I have a Shrootbuck, which is one word, and I have a Shroot space buck, which is one word. I have two different completely separate wallets here, contracts here, that I'm looking at, and I go, I don't know which one to choose. So my friend might say, well, hey, it's related to this. I saw a GitHub page or something like that. So in our OSINT minds, we're starting to think to ourselves, wait a second, I know how to look into stuff like that. So here I go and I find, I'm just doing a basic search for Shrootbuck. Thanks, Chris. And the basic Shrootbuck here in this GitHub page it's talking about a project they have running here, and they're telling us really what the purpose of it is. Now, here's the hard part for me in investigating crypto overall is I always have to ask myself, what is the point of this thing? What does this thing do? So these people here are telling us that if you send us a 0.001 ETH to this smart contract here, or this wallet, so 0.001 ETH to this wallet right here, you'll receive one SRB or Shrootbuck. So that's what they've called it, is this SRB. But you need to give me 0.001 ETH. So if we look at the page, again, this is just a GitHub page up here that they've created. Can we do some additional OSINT stuff to see if there's any sort of CNAME or anything else, or any sort of information about this particular username? I think they've chosen Creed is the man as their username. And down at the bottom, we have they're kind of telling us a little bit about how this thing works. So they're giving us 0.001 ETH, and they're telling us that there's been one Shrootbuck issued out of, so total, of course, according to this page, out of, carry the one, so 19,660,120 Shrootbucks. They've set that artificial limit, saying this is a limited time only. We're going to only issue 19,660,120 Shrootbucks. Okay, so they're telling us a little bit about this. Now, there's some. You go to this page. It's I'll give you this links at the end, but it's creedistheman.github.io. And if you click on the bottom, it actually doesn't go to a real website. There's a link out here, and it's kind of an inside joke, or a very it's I guess you want to say it's like kind of like Easter egg that's within the office itself about why they're linking out to a site that doesn't exist. So just FYI, www is not a valid TLD or top level domain like .com is. It's not valid. So kind of an inside joke there. So I'm going to go to this contract here, or this wallet, and check it out. So I'm on inside Etherscan right now. I'm actually on this wallet right now, and I'm looking at it. So again, we have the skills now to understand what exactly it is that we're looking at. And we can see the history here. Now, this is quite old. We have this first transaction is they created the Shrootbuck. And they created the Shrootbuck back in January 6, 2018. And we can see the first transaction here. So let's look at the very first transaction into here, where it says 0.001 ETH went in here to buy a Shrootbuck. So within the Shrootbuck itself, it says it interacted with this contract, this 173905, because somebody sent 0.001 ETH into there. And we can see that indeed, they did get one Shrootbuck back. So the tokens transferred are from this contract sent back to this wallet, which was the original wallet that sent the 0.001 ETH. They sent them one SRB. Okay, so now they have that SRB, great. Now let's look at the contract itself. So within the contract itself, let's go back to the page itself, and we have this little contract button right here. So this is, if this is a contract, there'll be a little contract button here, very, very convenient for them. Now, not all contracts look like this. If they publish a contract, you'll be able to see the actual contract language itself. And you'll see at the top here that indeed it was submitted for verification. It tells us when that thing happened on January 6th, 2018. And then we also can see that here that it's written in Solidity. That's the programming language for these, the code for these particular contracts. So they wrote this contract, says that they're calling this contract the Shrootbuck, again, Shrootbuck without a space. And they're starting to name some things down here. Now, you'll see a lot of this stuff is, you'll see that very familiar number here. So the max total supply, they're naming that 19 million number. That's specified in the contract. You can see how that code is starting to work, even if you don't understand code. We can also see how they are naming their particular token. So they're calling this an SRB. So Shrootbuck, right? And they're calling the Shrootbuck. And if you keep going down here a little bit further, we can see a bunch of other code down here. Actually, there's a little funny blurb that they put in here that doesn't really do anything to the contract itself. Let's see if I can find it. There we go. So they put a string as a public fact is bears eat beets. Okay, so completely random, not necessary. So this might tell us this might be just a joke kind of contract. Somebody just did maybe an experiment. And down at the bottom, you see a bunch of code that's basically going to tell us about the things that this code is doing. A lot of it's going to say, hey, this code is being putting in here. Again, it's just a code that's being thrown into there because there's known exploits within these contracts. So there's a bunch of code that's basically kind of copied and pasted in here, and it's telling us, hey, this code, some of the comments saying right here is saying it's mitigating the ERC20 spend approval race condition. One might be solving another problem. So going back to the code part is that people are creatures of habit. If we found another token that somebody else had written that we had some sort of inside knowledge, we can maybe compare this code. If they're pasting it exactly the same way and in the same exact order, that starts to give us some more level of attribution as well. Now, is it 100%? No, because it's only one piece of the puzzle, but we have to be aware that people are writing this code. And when people are writing code, believe it or not, people just copy and paste a lot of other people's stuff. And they copy and paste their own stuff just to make it work because they know it works. Because for sure this works is because you transferred that one over. Now, if we looked at the other Shrootbuck, okay, let's just go, wait, which Shrootbuck is really real? I'm not quite sure. I look at another Shrootbuck, there's not a lot of information about this one. We look at the days that it happened. It actually happened back in 2016. So 2 years prior to the other Shrootbuck. All right, so that tells us, okay, maybe this is the original Shrootbuck my friend was telling me about. There's not a whole lot of information happening here. If we went to the contract section here, we'd see a bunch of goobly-gap or hex information. When they don't verify the contract with and publish it with Etherscan, this is what you're going to see. You're not going to be able to do a whole lot with this particular button. But what I will say is that I didn't cover on the other one is there's a similar contracts button that Etherscan is actually built in. So how are they, putting these things together? Well, they're looking at maybe code, whatever program they have is looking at code and things like that and trying to tell us if another contract is exactly like this one. We're not going to get a whole lot back from here because, again, this is just bytecode down here, and we don't understand what this really is until we have some sort of decompiler, which is way above what we're going to be talking about today. But to understand the differences between these contracts and how they're published and how we can look at them. Okay. All right, so now we understand everything about Shrootbucks. I'm sure you're all going to, please don't send 0.001 use that person. You can if you like, I can't stop. But then now we're going to talk about more information we can possibly find from this information. So let's talk about messages and transactions. Okay, so default in a message is just a binary code inside the message. The great thing about what Etherscan has done for us is given us the ability to look at those messages and to decode that automatically without using any special tools. Now, I gave a transaction hash ID way down here at the bottom. If you want that later on, we can take a look at it. But I'm going to show you a way to spot all messages with transactions with them quite easily on here on Etherscan. So this wallet here is this Arthur's 0x's wallet. I'm not too familiar with the individual. He's big in the Web3 space, and he was a victim of a hack, a crime where a bunch of his NFTs were taken and a bunch of stuff was transferred out of his wallet into this wallet. So this is an actual crime here, not one I'm investigating. But there's a bunch of stuff that went out from these places and had transferred crypto assets. So if I wanted to look at transactions that had messages attached, Etherscan has actually done an interesting thing for us, and they put a little asterisk next to these transactions. You hover over it, it says, hey, this has some data inside the transaction field. You might want to click on this to check out what the message might be. Now, this is not a secret or anything. If you click down in the transaction, which we already know how to do, and we click see more, we see some input data. Remember I told you the input data looks just like that other bytecode you saw, the binary data. If I go into UTF-8, I can actually see some websites now. I see some Pulse Lead XYZ. I got some GitLab information. So this particular message really, let's look at where it's coming from itself. This is a default message. If we looked at all these transfers here, so let's understand the directionality of this. This is coming from an ES name, pulsechain.com.eth. Again, an ENS name you're going to understand later on. So this is an identified wallet on the Ethereum blockchain. Assets are being transferred from here into this wallet hacker's wallet here. So this is the actual heist itself. And you see here at the top, we talked about attribution. It actually tells us, hey, this address has been reported to involve exploiting Arthur X's wallet. It's a big thing, and it's tagged under exploit and heist. So if we were dealing with this wallet, it's now persona non grata, because if you're dealing with this person and you know this is going on, you're either in it with them, or you are completely oblivious to how this entire system works, which makes you wonder why you're trading crypto in the first place. But realize there's some crime going on here, and this crime is actually very well self-reported inside of the industry itself. So it makes it very helpful for us when we run into these things. At the same time, could I have just Googled that particular wallet? Yes. And because Google, does all these indexing and things like that, it would actually lead us right to that place, most likely, because it's been mentioned in articles, it's been mentioned a lot of other places. And again, when we read these articles, now we understand what's actually going on. So let's briefly dive into layer 2 and understand what layer 2 is. So I talked about it before, where there's technology that's been built off of the Ethereum blockchain to interact with it. Some code's been written and people have been doing things. Most of the time, people are writing this code because they want it to have some sort of interoperability with Ethereum blockchain without building their entire other chain themselves. So they use that as a bridge. And within their own their little ecosystem that they've built, they can do things like transactions and all that. However, when those things happen, that value has to come back again as part of the L1, the mainnet. So that value eventually, in some way, shape, or form, has to come back there as well. And so you'll see that here in just the next example, where we look at zk-sync. Now let's go back to our original wallet. So again, I like to bring everything full circle here. And then original wallet had a lot of transactions on it. Well, at least when I first looked at it, it didn't. Now I want to look at the total transactions. Notice here at the top, there's 66 transactions. I can't look at all of them here. zk-sync is way down at the bottom. I have to show there's 100 records here. And down at the bottom, I'll zoom in here just a second. You can see that there is some transactions out to zk-sync. There's 3 transactions here. When you see the 0 Ether ones, those are going to be on either ERC20 or ERC721 side, and the other one is 0.001 ETH. And so we had some funds, some crypto assets that were sent out to zk-sync. Now, when I first looked at this, again, this is just a random wallet I looked at, I didn't know what zk-sync was. There are so many different L2 type things out there. I had to research it myself. So when I researched it, I found that, okay, zk-sync had a GitHub page. They tell us about why zk-sync is a thing, how it works. And they're telling us a lot about, how the interoperability works. So when you go to the zk-sync site, so again, now let's picture our minds. These funds have gone from this wallet out to zk-sync, and they're just sitting there now. Because if you go further up in the transactions, again, it's oldest to newest, that those funds are still sitting in zk-sync. Well, what are they doing there? Well, so we're going to have to figure out what that wallet, the address of that wallet is. So let's go back to that wallet real quick. We'll copy it and we'll look at zk-sync's chain itself that they've built, and we can look at the transactions itself. So I'm going to highlight this. I'm going to copy it, go over here to the zk-sync side. And if I go here and I go, now what's going on here? I have a wallet, I have a checkout, I have a block explorer. So I click on the block explorer and it brings me to another page. And if it ever loads up, I can put my wallet inside here. Again, this wallet exists on the Ethereum blockchain, and it also exists here over in zk-sync because this is a separate service. Now within zk-sync, I can see that there is the address here, and I can see it down at the bottom where some funds, again, these are going to mirror what happened on the Ethereum blockchain, but these funds are now, see, it's coming from L1, just sitting coming from the L1 now, just sitting here in zk-sync, doing whatever. They send some USDT, you can see here the 40 USD and 30 USDT, and they send some ETH. Now, eventually this person can change these things out here if they like. They could do whatever ZK things that they're allowed to do here. And then they can send that value back to their wallet itself. But again, these wallets are interlinked. But if you want to see the transactions that are happening here on this service, you need to go to the service page itself. And it's at this point you might think to yourself, well, this is a lot of information to take in, and it's really hard to think about all this as it's going on, because again, there are so many different layer 2 places. I've listed a couple examples here for you: Polygon, or what some people call Matic. There's also XDAI, and of course Binance as their smart chain. And there's also other chains that are basically completely separate from Ethereum, if it's not confusing enough. And those chains do completely separate things, like AV and other blockchains like that have really no relation to the Ethereum blockchain itself, but they're basically kind of copycats off of Ethereum a little bit itself. So on a side note, we're kind of running down here towards the end. On a side note, now some people ask me, how do we keep track of this information? And so before we talked about some paid tools. Before, when we talked about paid tools, I said, hey, some people mentioned here that they are expensive. Yes. And in fact, some of these paid tools don't even do this Ethereum blockchain tracing, not with all the different, you've seen all the different tokens that are out there. And if you're familiar with the ecosystem, there's way too many to keep track of. And not all tools can support all tokens. Inevitably, what's going to happen to you is if you're doing this, you're going to run into a token that's not supported. So just because your fancy, expensive tool doesn't do it, does it mean you don't do it? No, I mean, it's OSINT. So we do things we just figure it out. So what I did before our fancy tool started doing any sort of visual ETH tracking, what I did was I started doing these things in multi-go case file myself. Now, what I'm doing here is not automated at all, okay? This is not automated. I'm doing everything by myself here. I'm just putting this information in myself. So realize that all the things that I'm doing here, this is not something that I'm having Multigo do for me. So we have this original user information here, where this is the wallet we were just talking about. This is our first wallet we talked about. And that wallet has some funding coming from Gate.io, and has some coming from Binance, and has funding coming from FTX. Now, if they had information going back to these wallets, then I could draw those relations back. We can even see the relation here. So we're seeing that, again, I'm used to using buildings as organizations. It's going back to ZK Sync. And of course, now I'm looking at other transactions here. Again, there's a lot more transactions than this, but maybe it's just the ones I'm interested in. So this transaction goes out here to this particular wallet here. This wallet here transfers it to another wallet. Okay, or actually they transfer an NFT out to this wallet. Let's kind of zoom in a little bit here. They transfer this an NFT, which Michael James is going to talk about. And then that NFT basically gets transferred to another wallet for some funds. So we see some financial transactions going on here. And this wallet here is actually getting funding from Binance. So if I want to figure out who this was, there's a possibility I might be able to find some relation there. Okay. So with all that said, if you want some further information, I can paste some of this other information into the Slack. Now, we said before that Slack is going to be going away because this isn't a full-time Slack here, but you have my contact information. Can't even make the screen go big anymore. You have my contact information, and if you need anything else from me, yeah, there he goes. My machine's running a little bit behind here. So if you need any of my contact information, please let me know. I can't answer all questions all the time, but I can do the best I can. And all I'll say is that whenever you run these problems, if you find a new token or any sort of new cryptocurrency, it's always going to be a research project. So you use your original OSINT type skills you already have, and you just apply that to here. Try to wrap your brain around how it actually works.